Hello, Algebra 1 students. Yesterday you did some interval notation, so make sure you check off once that practice is done and once you've taken the quiz. Stay organized, and that's going to be really helpful for you. Today you're going to do combining like terms, and you can check that off. And go to that page. When we combine like terms, you need to know the difference between variables and like terms. So a variable, I believe you know this, is a symbol that represents an unknown value. So examples of symbols that represent unknown values, of course, X and Y. Those are our favorites. But you really use any symbol. So you could use T, you could use Q. Some people like I. Notice how when I do my T's and I's, I always put the little curve. Same with J. We like to have the little curl on the end so we know what's going on. Like, look at my Y. If I write Y like this, it kind of can look like something weird, so I like to put the nice curl so I know what it is. Anything. It could be smiley face, really, if you want. Some people even use question mark as a symbol, so that's one thing you could do. A like term is a variable. However, it's a variable that has the same exponent. So like terms need to be like 2x and 3x. Those are like terms. Even though there's different amounts of them, they have the same variable x and the exponent is 1. So if we also had y to the third and 5y to the third, those are also like terms. They have the same variable y and the same exponent. Then we can put them together. One more example, if we have the third root of 5 and 5 third roots of 5. Okay, it's got the same base, that third root of 5, and the exponent is technically that same root. Those are like terms too. Those are the ones that people have the most trouble with. So let's do some examples. So number one, we have 7x and 2 more x. Okay, if we have 7x and 2 more x, that's a grand total of 9 x's, right? We're just adding them. They're like terms because they both are x and they both have the same exponent. This is 7x plus x. So how many x's is this x? Well, there's only one, right? We don't always write that one, we just write it as x. So 7x and that one more x is 8x, okay? Grand total of 8x. Number 3, we got like terms here. We've got xy and xy. They have the same variable and they have the same exponents. We can put those together. So how many xy's do we have? Well, we have 2 xy's. Then I'm going to switch colors to show you that these numbers can go together too. All right, they're both numbers. They're just numbers. They don't belong with those letters. They need to stick together as numbers separately. So -1 and -1 is -2. So our final answer is all of this. We have square root of 3 and square root of 3. Those both are the same type of root. Notice how it's the exact same root. There's no numbers that are different. And it's both root of 3. So if we add those together, we can get 5 square roots of 3. And that's it. So we have a property here. It's the commutative property. All right, where this means that the order does not matter when you add, subtract, and multiply, as long as the sign in front stays the same. So what we mean by the commutative property, if we did 8 plus 6 first and got 14 plus 10, which gives us 24, we could also say that 8 plus 10 plus 6. See how it's a different order? It's fine. 8 plus 10 is 18, plus 6 is 24. Notice how it's the same? Even though the order was different, we added the 8 and the 6 first in this one, we added the 8 and 10 first in this one, it doesn't matter. The order, as long as you keep that sign, you're fine. So with this one, we have negative 2 plus 3 is 1. 1 minus 1 plus 5. 1 minus 1 is 0. 0 plus 5 is 5. But if we switch the order, we could have also said negative 2 plus 5 plus 3 minus 1. Now notice that I moved that negative 1. The sign needs to stay with it. So I put it at the end. It's going to give us the same answer. So negative 2 plus 5 is 3, plus 3 minus 1. 3 plus 3 is 6. 6 minus 1 is 5. They're both the same answer. So again, the order doesn't matter as long as you keep the sign that's in front with the number. So that is a negative 1 that needs to stay. So you can use this commutative property to your advantage. So if you've got like terms, we have x squared and here's a minus x squared. We can put those together first using that commutative property. So 3x squared minus 1x squared is 2x squared. Then we've got negative 7, and I'm looking for another number, which is 2. Negative 7 plus 2 is negative 5. And 4x cubed is by itself because that's a separate exponent. We can't combine it with that. It's a different exponent. So we have plus 4x cubed. Done. Let's look at 4. So we're looking for x squareds because it needs to have the same letter and the same exponent. So same x's, same exponent. 10x squared minus 3x squared is 7x squared. I use that commutative property by switching the order and doing those two first. Then I can do 5x minus 7x. It's negative 2x. We can't combine them because this is x squared and this is just x. They need to have this exact same exponent, so that's done. Number 5, we're looking for the same root. So we have square root of 6 and 2 square roots of 6. So negative 3 plus 2 is negative 1 square roots of 6. Then I have square root of 3 with square root of 3. So 3 square roots of 3 minus 5 square roots of 3 is negative 2 square roots of 3. Done. Number 6, we have 2x cubed and 4x cubed. Those are the only ones with the exact same variable and the same exponent. So this is 6x cubed. Then notice these are not like terms. There's nothing to combine. We're just going to copy them down. Plus 3x plus x squared. Remember, those have different exponents up here. This exponent is 3. This exponent is 1. This exponent is 2. Because they're different exponents, we cannot put them together. So that's one's done, believe it or not. 7, we're looking for xy's. Well, there's another xy right here. So there's 1 xy and 4 xy. So that's for a grand total of 5 xy. Then we have negative 7x and negative 3x. Okay, they're the exact same variable and the same exponent of 1. So this is negative 10x. And finally, this 9y can't be combined with anything because it's the only one with just y. Plus 9y. And last, we have cats and cats. Notice this is cat. In algebra terms, cat does not combine with cats because that is these are 4 letters. This is 4 letters. That cat is only 3 letters. So technically that's not a like term. So we have 4 cats plus 3 cats is 7 cats. And then we could say minus cat. Notice how they're not different. This is cats. This is only singular cat.